Hi everybody, and once again welcome to Pankaj's Echelon Tutorials. In this today's session we are going to deal with physics, and in physics I'm going to start with a topic called distances in solar system. And let me tell you, this is pertaining to chapter number 24th. Okay, now this is from the David Sang book, the third edition that I'm talking about. Okay, so chapter number 24, which is solar physics. Okay, and from this chapter I've taken this topic called distances in solar system. Now this distances in solar system, I'm going to explain you this concept with the help of certain numericals, right? So let us get started with, so first of all, the distance between the sun and the earth is everybody should know by now that it is 150 million kilometers, right? Now 150 million kilometers can be written as 150, and then million means 60. So 1, 2, 3, 4, 5, 6. Okay. So 150 and then 6 zeros kilometers. This is how 150 million kilometers is written. Now this can be again in the scientific notation can be written as 1.5 into 10 raised to 8 kilometers, right? And again this can be written as 1.5 into 10 raised to 11 meters. So when I convert kilometers to meters, this 10 raised to 8 will get converted to 10 raised to 11. This is all simple basic mathematics, so I don't want to go more in detail in that. Okay, so this is the distance between the sun and the earth. Okay, with this as the information, let us try to see what can be done. Now time required for the light to travel from the sun to the earth is how much? Okay, so this is a big question that everybody wants to know, that what is the time required for the light to travel from the sun all the way to the earth. Now this particular question can be dealt with in this way. Now speed is equal to distance upon time, so time will be equal to distance upon speed. This formula can be used very nicely. Time is equal to distance upon speed. So distance, we are talking about the distance between the sun and the earth, right? So the distance between the sun and the earth is this distance, and the speed is, we are trying to find out what is the time that will be required by the light to travel from sun to earth. So we are talking about the speed of the light. So the speed will be of the light. So speed of the light and the distance between the sun and the moon. So let me write the distance between the sun and the moon as 1.5 into 10 raised to 11 meters, right? And let me write the speed as 3 into 10 raised to 8 meters per second. Okay, meter per second. Now I have chosen the distance in meters and I have chosen the speed to be in meter per second. This way what happens, both are in the SI system. Okay. Now 1.5 upon 3 can be calculated separately, and this 10 raised to 11 upon 10 raised to 8 can be calculated separately. So 15 into 1 is 15 upon 10 into 330, and 10 raised to 3, 11 upon 8 will be 10 raised to 3. So this will give me the time required in seconds. This will work out to 0.5 into 10 raised to 3 seconds. That is nothing but 500 seconds. And if I want to convert this time into minutes, then 500 into 1 by 60 will give me the time in minutes, and that works out to 8.3 minutes. So the answer for this particular question, that is the time required for the light to travel from the sun to the earth, is how much? It is 8.3 minutes. Okay. Now let us do the same thing for some other set of planetary objects. Suppose the question is, the moon is 390,000 kilometers away from the earth. Calculate the time taken by the light to travel from the moon to the earth. Now this is similar to the previous one. Again, the formula that I will be using is time is equal to distance upon speed, and this time the distance will be 390,000 kilometer. I'll convert it into meter and write it 390,000 kilometer, right? This is in kilometer, and in meter it will be 3 more zeros. Okay, so this happens to be the distance in meters, and the speed I'm going to keep it in meter per second only. So it is 3 into 10 raised to 8 meter per second. Now again, this meter and this meter per second both are in the SI system. Now what I'll do is 39 into 10 raised to 7 I can write, and 39 and 3 will cut, and I will get a 13 over here, right? So I'll get a 13 over here. and 39 upon 3 is 13, and this zeros are how many? 7. So 10 raised to 7, and this 10 raised to 8 is there in the denominator. So this will give me the time in seconds. So 13 into 10 raised to 7 upon 10 raised to 8 is 10 raised to minus 1. So 13 upon 10 equal to 1.3 seconds. So this is the answer. So for the light to reach from the moon to the earth will be 1.3 seconds. Okay, in minutes if you want to find out, then 1.3 you have to divide by 60. That will give you the answer in minutes, and that will work out to around 0.022 minutes. The next question is, how long will it take for the light from the sun to reach Mercury and B, Neptune? Okay, so there are two planets now we are talking about, and the distance between the sun and the Mercury, sun and the Neptune are given over here, right? So let us deal with this question as well. Okay, so the A one first we'll deal with. Same formula, time is equal to distance upon time. So the distance is 60 million kilometers. So it will be 60 and then 6 zeros, and 3 more zeros I'm adding, so that the distance is now in meters. So this is the distance in meters, and the speed of the light will be as usual 3 into 10 raised to 8 meter per second. And now if I work out this, will this I can write as 6 into 10 raised to 10, because there are 10 zeros I can see over here. So 6 into 10 raised to 10 divided by 3 into 10 raised to 8. Now 6 upon 3 will work out to 2, and 10 raised to 10 upon 10 raised to 8 will work out to 10 raised to 2. So ultimately the time will be 2 into 10 raised to 2 seconds. That is 2 into 100 seconds. That is 200 seconds. So this is your answer. And if you want the answer in minutes, then 200 divided by 60 will give you the answer in minutes. And that works out to 3.34 minutes. Next, B. B is the Neptune planet from the sun. So the time required for the light to reach from the sun to the Neptune planet will be how much? The distance is 4500 into 10 raised to 6 kilometer, and the speed is 3 into 10 raised to 8 meter per second. But this will not work, because this is in kilometer, this is in meter per second. I'll have to see that both are in the SI system. So what I'll do, this kilometer I'm going to convert it into meter. So 45 into 10 raised to 6 and then 7, 8. Okay, and 3 zeros I'll add for making it into meters. So 10 raised to 11. So 45 into 10 raised to 11 meters will be the distance in meters, and speed will be now 3 into 10 raised to 8 meter per second. Now both are in the same system, SI system. Now let us see. So 45 upon 3 will work out to 15, and 10 raised to 11 upon 10 raised to 8 will be 10 raised to 3. So it will be 15 into 10 raised to 3 seconds. So 15 into 10 raised to 3 is 15,000 seconds. So the answer for this is 15,000 seconds, or if you want it in answer in minutes, 15,000 you will have to divide by 60, and that will give you 250 minutes. That was the B part of this question. Next question is, how many kilometer is there in 1 light year? Now first you should know what is the meaning of a light year. Now light year, 1 light year, Ly, is nothing but the distance traveled by light in 1 year time. Okay, so this is the definition of 1 light year. 1 light year is a unit of distance. Okay, mind you, 1 light year is a unit of distance. It measures the distance between the planetary objects. Okay, very very large distances, and 1 light year is equivalent to the distance traveled by the light in 1 year time. Okay, so we know that the speed of the light is 3 into 10 raised to 8 meters per second. This means that the light travels 3 into 10 raised to 8 meters in 1 second. Now we want the distance that will be traveled by the light in 1 year. So this is 1 year, this is 1 second. Now I want to make the unit same on this side. Okay. So what I'll do, this 1 year, I'm going to convert it into seconds. Now how I'll do that? So 1 year is equal to 365 days. Okay, but in 1 day there is 24 hours, so I'll multiply by 24. But in 1 hour there is 60 minutes, so I'll multiply by 60. And in 1 minute there are 60 seconds, so I'll again multiply by 60, so that I get the final answer in seconds. Okay, So 1 year will be equal to 365 into 24 into 60 into 60 seconds, right? Now instead of this 1 year, I will write 365 into 24 into 60 into 60 seconds. Okay. Now I will get my answer for 1 light year. Okay. So 3 into 10 raised to 8 meter multiplied by this particular quantity will give me the value of 1 light year. And that will be in meters. So here I have written everything. So distance in meters, okay, will be equal to, distance will be equal to, this I'll write here. This distance will be nothing but 1 light year. Okay. So this distance will be equal to 3 into 10 raised to 8, right? Okay. Yeah. This distance will be 3 into 10 raised to 8 meter per second multiplied by this 365 into 24 into 60 into 60. Now this can be rearranged and written as 3 into 10 raised to 8 into this particular thing, this what I'm underlining right now. This will work out to 31536,000. Okay. So this many meters will be the answer. 1 light year will be equal to this many meters. Now again this 31536,000 multiplied by 3 will give me 94608,000. That multiplied by this 10 raised to 8 meters. Okay. And this particular thing now I am going to write in scientific notation form. So I'll put 9.46 into 10 raised to 7 instead of this. Now this what I am underlining now, right now. If I convert it into scientific notation, it will be 9.46 into 10 raised to 7. And this 10 raised to 8 is already there. So this will be the answer in meters. Now let me reduce this for 9.46. I am rounding to 9.5. And this 10 raised to 7 into 10 raised to 8 will work out to 10 raised to 15. And this is meters. So this is my answer. 1 light year will be equal to 9.5 into 10 raised to 15 meters. But they have asked you how many kilometers is 1 light year. So I have got the answer for 1 light year in meters. Now if I want to get the answer in kilometer, this meter I'll convert in kilometer. For doing that, I'll divide by 1000. So it will become 9.5 into 10 raised to 12. Okay, kilometer. So this is the answer. So 1 light year is equivalent to 9.5 times 10 raised to 12 kilometers. Now the next question is, suppose now he's talking about, I think, Neptune and Sun. Okay, the distance between them he has asked you to find out. Okay, the distance. The question is, find the distance between Neptune and Sun if the time required for the light to reach from Sun to the Neptune is 43 minutes. Okay, this is the question. This time he has asked you to find out the distance. Okay, so again, time is 43 minutes. So 43 into 60 will be 2580 seconds. So if I want to convert this minutes into second, I will multiply by 60. And this is the time required in seconds. Now what I will do is, I want to find out the distance. So speed is equal to distance upon time. So distance will be equal to speed into time. So speed of light is 3 into 10 raised to 8 meters per second. Okay. Okay. I've written that per second below. Okay. Meter per second, right? Multiplied by the time. Now time should also be in seconds. So I'll take not 43 minutes, but 2580 seconds. Okay. Now this second will cut, and I'll be left with 3 into 10 raised to 8 into 2580. That will be the distance in meters. And when you work out this, you will get 7.74 into 10 raised to 8 kilometer. So this is the distance between the Neptune and the Sun. So with this, I have completed so many numericals. Okay, and all these numericals were from the David Sang book, the third edition, the recent book. And this was for the 10th grade IGCSE physics students. Okay, so that's all for today. And if you happen to like my video, please subscribe to my channel, and that will help me, and that will motivate me, and that will help me in making more and more such videos. Okay, so that's all for today. See you next time in the next video. Till then, goodbye. Take care, all of you.